In this video, I will be covering some basic techniques that are used when factoring polynomials. Here are some of the techniques that we will be covering this video. It might seem like a lot to memorize at first, but eventually it will get much easier as we go through some practice problems and examples. When doing any type of factoring problem, you always want to look for the greatest common factor. Let's say we're given the problem 8x plus 4. Our greatest common factor would be 4, since it goes into both of these terms. So what we want to do is factor out the 4 from this. So what you're really doing when you factor out 4 is you're dividing both of these terms by 4, like this. So when we do that, 8x divided by 4 equals 2x, and 4 divided by 4 equals 1. So what we're left with in the bracket would be 2x plus 1. And that's how you factor using the greatest common factor method. Let's try another problem. Let's say we're given 42x cubed plus 6x squared y. So how would you factor this? So we can identify how you can factor out 6 from both of these, and you could factor out x squared from these two. So what we're left with is 6x squared brackets and 42x cubed divided by 6x squared. We're left with 7x. And 6x squared y divided by 6x squared, we're just left with y. So this would be our answer. So let's try these two questions. 3x minus 9 and 27x y 6 minus 3x squared y cubed. So I'll let you do it on your own. Feel free to pause the video. For the first question, our greatest common factor is 3. So we can divide 3 out of both of these terms, and we'd be left with x minus 3. And that would be our answer right here. For the second one, it's a bit more complicated, but we can divide a 3 out of both of these terms. We can divide an x out of both of these terms. We can factor out a y cubed out of both of these terms. And so in total, we're factoring out 3x y cubed. So inside the bracket, we would have 27 divided by 3, which is 9. The x's cancel out, and y to the power of 6 divided by y to the power of 3 is y to the power of 3. And for the second term, the 3's would cancel out, and we have x squared divided by x. But notice the negative sign here. So it would be negative x. And the y cubed and y cubed here would cancel out. So this is our final answer for the second question. Now we will be going over how to factor binomials, specifically using the difference of squares method. This method is used when both terms can be square rooted and there's a minus sign in between the two terms. Here's an example. Let's say we're given x squared minus y squared. When you get something like this, you have to recognize that it is factorable using the difference of squares method. So the answer for this will basically be x minus y and x plus y. We will be going over some more examples involving numbers, but this is the general rule right here. So we know that the general rule is that x squared minus y squared in its most factorable form is x minus y and x plus y. So how would you factor something like this? X squared minus 64. So when factoring this, you just want to get the square roots. So square root of x is just x, and square root of 64 is 8. And then you want to have a minus sign on one side and a plus sign on the other side. And that's how you do it. Let's say you're doing a factoring test and you finish the test 30 minutes early. Instead of handing in your test, what you can do is check over all your answers by doing this. What you basically want to do is distribute out your factored answer and make sure that they end up the same as what you were trying to factor in the first place. So let's try checking this to make sure it's right. So basically what we want to do is distribute this out right here, like this. So our answer would be x squared plus 8x minus 8x minus 64. And the 8x cancels out because one is positive and one is negative. So what you're really left with is this, and that is x squared minus 64, which is the same as what you were given here. So you know that your answer is right, assuming you did the math properly when checking. Let's try a few more practice problems. X squared minus 9, 4x squared minus 16, 25x squared minus 36, and 25x squared minus 36y squared. Feel free to pause the video and work on this by yourself. So for the first question, x squared minus 9. This one's pretty easy. It's just square root of x and square root of 9, which is 3, and a negative sign on one side and a plus sign on one side. 4x squared minus 16. This one is a bit more tricky because we have a coefficient in front of the x squared. So basically, when we square root that, we're left with 2x, and the square root of 16 is 4. A negative sign and a positive sign on one side. The next one, 25x squared minus 36. So the square root of 25x squared is 5x, and the square root of 36 is 6. Just like this. So the next one, similar to the third question, 25x squared minus 36y squared. So the square root of 25x squared is 5x, and the square root of 36y squared is 6y, and positive sign and negative sign on each side of the bracket, just like this. And that's how you factor using the difference of squares method. Let's try factoring by grouping now. This method is primarily used when factoring things that have 4 terms. It's sort of similar to the common factor method. I'll go through some examples so you can understand. So, let's say we have 2x cubed minus 6x squared plus 5x minus 15. Since 4 terms is big, what we can do is basically group them into 2 separate terms. It will be easier to factor this way. So imagine that we have an invisible line basically between this. So what we're trying to factor is this part right here and this part right here separately. So let's factor out the first part. 2x cubed minus 6x squared. What is the greatest common factor here? So we can factor out a 2x squared. And when we do that, we're left with 2x cubed divided by 2x squared is just x, and negative 6x squared divided by 2x squared is negative 3. So we're left with this as our first part. And then for our second part, we have 5x minus 15. Our greatest common factor here would be positive 5. So we can factor positive 5 out. So 5x divided by positive 5 is x, and negative 15 divided by positive 5 is negative 3. So this is our second part. So I'll write this out more neatly. So we have 2x squared bracket x minus 3 plus 5 bracket x minus 3. So basically, what can we factor out of this? Well, we have two things in common. We have x minus 3 on both sides. So we can take out an x minus 3. So when we do that, we're left with x minus 3. And all we're left with here is 2x squared and positive 5. So in the other bracket would just be 2x squared plus 5. And this would be our final answer. Let's try another problem. Let's say 4x cubed plus 2x squared minus 2x minus 1. How would you factor this? So let's split it into its two groups. So let's do the first part. 4x cubed plus 2x squared. What's the greatest common factor here? Well, it's 2x squared for this. So inside the brackets, we would have 2x plus 1. For the other side, we can factor out a negative sign, basically, negative 1. So what we're left with in the brackets is positive 2x plus 1. So with this, what can we factor out further? So we can factor out these two things right here. So we have 2x plus 1 in one bracket, and what we're left with is these two terms here. So 2x plus 1 bracket, and the other bracket is 2x squared minus 1. And this is our final answer here. Let's do two more practice problems. For the first question, we'll have 2x squared plus 8x plus 3x plus 12. And for the second one, we'll have 18 minus 15x minus 6x plus 5x squared. Feel free to pause the video and work on this by yourself. So for the first question, we can split this into its two groups. For the first group, what can we factor out from 2x squared minus 8x? We can factor out a 2x from it. So we're left with x plus 4 in the bracket. For the second part, what can we factor out from 3x plus 12? We can factor out a positive 3. So 3x divided by 3 is just x, and positive 12 divided by positive 3 is just 4. So we can factor out the x plus 4 from this. So we're left with x plus 4. And we have these two remainders right here, 2x and positive 3. So then we can bring them down here, and the other bracket will be 2x plus 3. And this is our final answer for the first question. On to the second question. Let's split this into its two groups. So for the first group, 18 minus 15x. What can we factor out of this? So we can factor out a 3. So inside the brackets, we'll have 18 divided by 3, which is 6, and negative 15x divided by 3, which is negative 5x. For the second group, we have negative 6x plus 5x squared. What can we factor out of this? We can factor out a negative x. So what we're left with in the brackets is 6x, negative 6x divided by negative x, which is just 6, and positive 5x squared divided by negative x is just negative 5x. So these are two common factors here. And we're left with these two remainders right here. So let's write down our common factor. Let's factor this out so we have 6 minus 5x in this bracket and 3 minus x in the other bracket. And this is our final answer for the second question. Let's try factoring some trinomials now. We will start with the decomposition method. This method is used when the a value is not equal to 1. It is identical to the grouping method, but it requires one extra step. When using decomposition, you basically turn your 3 terms into 4 terms, so then you can split it into parts to factor it easy. Let me show you how it works. So, this is the basic trinomial formula. ax squared plus bx plus c. The a and b values represent the coefficients, and the c value is the constant term. Let's say we are given the trinomial 3x squared minus 2x minus 1. To factor something like this, we want to find two numbers that can add up to the b value and multiply up to the product of a times c. Let me show you. So for this question, our a value is 3, our b value is negative 2, and our c value is negative 1. A times c is 3 times negative 1, so negative 3. What are two numbers that times up to negative 3, but add up to negative 2? So we can think of some factors. We have negative 1 and positive 3, negative 3 and positive 1. So which one of these would add up to negative 2? So it would be the second one, negative 3 and positive 1. So now we can write it out like this. 3x squared minus 3x plus 1x minus 1. So here, we basically do grouping. We have 4 terms, so we can just think of it as 2 parts. We have the first part and the second part. So let's do the first part. Let's factor this out. What can go into 3x squared minus 3x? So then we can bring out a 3x. So what we have left in the brackets is 3x squared divided by 3x, which is just x, and negative 3x divided by 3x, which is negative 1. For the second part, what can we factor out from this? You can't really factor anything out besides really a positive 1. So we take that out, and we're left with the same thing, which is x minus 1. So for this, we have a common factor here. We can take that out. So our final answer will have x minus 1, and then we have these two things left here, these two numbers, 3x and plus 1. So in the other bracket, we'll have 3x plus 1. And this right here is our final answer. Let's do another question. Let's say we have 10x squared plus 17x plus 3. How would you factor this? So our first step is to find two numbers that add up to 17 and two numbers that add up to the product of 10 times 3. What two numbers can add up to 17 and multiply up to 30? Let's make a table. So 30, you can have 1 times 30. You can have 2 times 15, 3 times 10, and 5 times 6. So which two numbers can add up to 17? So we have right here 2 and 15. So we can write it out like this. 10x squared plus 15x plus 2x plus 3. So now let's split it into its two parts. So for the first part, what can go into 10x squared plus 15x? What can we factor out from this? So then we can factor out a 5x. 10x squared divided by 5x is simply 2x, and 15x divided by 5x is just positive 3. For the second part, what can we factor out? We can't really factor out anything, so we'll just put a plus 1 in front of the brackets and have 2x plus 3 inside of the brackets, just like up above. So, what can we factor out from this whole thing here? We can factor out the 2x plus 3 in the brackets. So we'll have 2x plus 3, and what we're left with is 5x and positive 1 here. So we'll have a 5x and plus 1 in the other bracket. And this is our final answer. Here's another question. 9x squared plus 6x plus 1. Feel free to pause the video and work on this by yourself. So, the first step. What two numbers can times up to 9 but also add up to 6? So let's make a factoring chart. We have 1 and 9, and we have 3 and 3. So this one would be the two numbers that we use. So we have 9x squared plus 3x plus 3x again plus 1. So let's split this into its two parts. So we'll have 9x squared plus 3x on the first part. How would we factor this? So let's take out a 3x. What we're left with in the brackets is 9x squared divided by 3x, which is just 3x, and 3x divided by 3x is just positive 1. So the first bracket is 3x plus 1. For the second part, what can we factor out? We can't factor out anything, so we'll just put out a 1 right there. So we're left with 3x plus 1 in this bracket. So what can we factor out from here now? We can take out the 3x plus 1 from both of these parts. 3x plus 1. And what we're left with is 3x and plus 1. So we can write it here. 3x plus 1. So we can simplify this to 3x plus 1 squared, since that's the same thing as this. And this is your final answer. We will be moving on to factoring trinomials using the inspection method now. This method is used when the a value is equal to 1. So basically, you don't see a number in front of the usual x squared term. This one is very easy compared to other factoring methods. Let's say we have an x squared plus 5x plus 6. How would you factor something like this? So the first step is to identify two numbers that can add up to positive 5 and multiply up to positive 6. So let's make a chart. So we have 1 times 6 that can equal up to 6. We have 2 times 3, and that's all. So, which two numbers can add up to 5? So we know it's 2 and 3. So we can write out our factored answer like this. X plus 2, and another bracket with x plus 3. And this is your final answer. So let's check if our answer is right by distributing it. So x times x is simply x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. So if we simplify this down, we're left with x squared plus 5x plus 6, which is the same as what we were given with at the start. So we know that our factored answer is correct. Let's try another question. Let's say we're given x squared plus 6x plus 5. So how would we factor this? So we know that we need two numbers that can add up to 6 but multiply up to 5. So let's make a chart. So 5, the only thing we could have here is 5 and 1. So here we can write it out like this. Our answer would be x plus 5 in one bracket and x plus 1 in the other bracket. So let's check this. X times x is x squared. X times 1 is just x. And 5 times x is 5x. 5 times 1 is 5. So when we simplify this down, we're left with x squared plus 6x plus 5. And that is the same as what we're given. Therefore, our answer here is correct. Here's another question. Let's say we're given 6 minus 5x plus x squared. This one's a bit more tricky because it looks reversed. So our a value would be here, our b value is here, and our c value is here. So knowing that, what two numbers can add up to negative 5 but multiply to positive 6? Let's make a chart. So 6, we can have 1 times 6. We can have negative 6 times negative 1. We can have negative 3 and negative 2. And we can have positive 2 and positive 3. So which two numbers here add up to negative 5? So it would be negative 3 and negative 2. So we can write out our answer like this. X minus 3 and x minus 2. And this would be our final answer. Try these two questions here. So y squared plus 21y plus 38. And try out x squared plus 9x plus 10. Feel free to pause this video and work on it by yourself. So let's work on the first question. What are two numbers that can add up to positive 21 and multiply up to positive 38? So here's a chart. 38. So we can have 1 times 38, and we can have 2 times 19. So which one can add up to 21? So we'd have 2 and 19. So our answer for the first question would be y plus 2, and in the other bracket, y plus 19. And this is our final answer for the first question. For the second question, how would we factor something like this? So this one was a trick question. So what two numbers can add up to positive 9 and multiply to positive 10? So let's make a chart here. Factors of 10, we can have 1 times 10, we can have 2 times 5. So which one of these add up to positive 9? So we can't do any of these. So this one would be not factorable. And this is how you do the inspection method. Now let's review what we have done in this video with a few more practice problems. Feel free to pause the video and work on these next couple of questions by yourself. And also feel free to slow down the video because I will be going a bit faster for these questions. So here's our first question. We're given x squared plus 14x plus 49. So how would we factor something like this? So for this question, we'll be using the inspection method. So what are two numbers that can add up to 14 but multiply up to 49? So those numbers are 7. So we'll have x plus 7 in one bracket and x plus 7 in the other bracket, which can also be written out as x plus 7 squared. And this is our final answer for the first question. On to our second problem. So our second problem is 4y squared minus 25. For this, we'll be using the difference of squares method. So we'll have something like this. So square root of 4y squared is simply 2y, and the square root of 25 is 5. And this right here is our final answer for the second question. On to the third question. For the third question, we're given 7x plus 7x cubed plus x to the power of 4 and plus x to the power of 6. So how would we factor this? So the greatest common factor here would be x. So let's factor out x from this whole thing. So if we factor out an x, we're left with 7 plus 7x squared plus x cubed plus x to the power of 5. So how can we factor this further? Inside the brackets, we have 4 terms, so we can use the grouping method. So let's split this into 2 parts basically. So what can we factor out of 7 plus 7x squared? So then we can factor out a 7 from that, and what we're left with in the brackets is 1 plus x squared. For the second part, what can we factor out of x cubed plus x to the power of 5? We can factor out an x cubed. So right here, we'll factor that out. And in the brackets, we're left with 1 plus x squared. So now, what can we take out from inside the brackets here? We can factor out a 1 plus x squared. So for the answer, we have x bracket 1 plus x squared. And what's left in the brackets here? We have 7 and positive x cubed. So we can write that down here. 7 plus x to the power of 3. And this right here is our final answer for the third question. For the fourth question, we're given 4x cubed minus x squared minus 4x plus 1. How would we factor something like this? So then we could use the grouping method. So let's split this into its 2 parts. For the first part, we can factor out an x squared. So 4x cubed divided by x squared is 4x, and negative x squared divided by x squared is negative 1. So for the first part, we have x squared bracket 4x minus 1. And for the second part, what can we factor out from here? We can't really factor anything out besides the negative 1, so then the 4x can be positive. So let's factor out a negative 1. So inside the brackets, we'll have 4x minus 1. From here, what can we factor out? So we can factor out the 4x minus 1. So we'll have 4x minus 1 down here. And what we're left with is x squared minus 1 right here. So, as some of you can see, this is not fully factored. This answer would only give you part marks on a test. So, for the x squared minus 1 bracket, it can be factored further using the difference of squares method. Let's do that. So, if we factor this, we'd get x minus 1 and x plus 1. So then we combine it with this. So for our final answer, we will have 4x minus 1 and x minus 1 and x plus 1. And this is our final answer for the fourth question. Let's move on to the fifth question. So for the fifth question, we'll be given 2x to the power of 14 minus 512 x to the power of 6. So how would we factor something like this? So as you can see, we could use the greatest common factor method to factor out a 2x to the power of 6. So let's do that. 2x to the power of 6. So what's left in the brackets? 2x to the power of 14 divided by 2x to the power of 6 is simply x to the power of 8. And negative 512 x to the power of 6 divided by 2x to the power of 6 is simply 256. How can we factor this further? So let's use the difference of squares method to factor the things in the bracket further. So let's rewrite this. 2x to the power of 6. So using the difference of squares method, we'll have x to the power of 4 in each of the brackets and 16 in each of the brackets. One will have negative and one will have a plus sign. So how can we factor this even further? So as you can see, we can still factor this term right here. So let's do that. Rewrite this as 2x to the power of 6 bracket x to the power of 4 plus 16, and let's use the difference of squares to factor this part even further. So x to the power of 4 square rooted is x squared, and 16 square rooted is simply 4. And we'll have a negative sign and a positive sign in each of the brackets. So as you can see, we can factor this one even further. So let's rewrite this again. 2x to the power of 6 bracket x to the power of 4 plus 16 x squared plus 4. And using the difference of squares method, let's factor x squared minus 4. So x squared square rooted is simply x, and 4 square rooted is just 2. So we're left with this. And this is our final answer for the fifth question.